Hello, this is the project presentation for TurbECS, a turbo entity component system. But first, the team. My name is Edward Leone, and I'm a computer science major with a minor in communication design. With that said, the problem. Modern game engines honestly overwhelm a lot of new developers. Again, I'm primarily looking at engines such as Unity, Unreal, Godot, whether it be just choice paralysis in the sense that they give you a lot of tools to immediately work with and expect to just go from the ground running. Or whenever just testing, a lot of time between making a change and testing that change. They can be overwhelming, they can be frustrating. So, a solution. I wanted to make an accessible development framework for developers, still with modern approaches in mind. That brings me to Turbo, a Rust-based game engine. At its core, it offers developers many tools. It is a 2D game engine. It allows for easy web publishing. So if you wanted to make a game and release it on itch, when you export with Turbo, they'll provide you a www folder, zip that, upload it to itch, you're good to go. If you want to do anything with like online connectivity, if you want to do anything with servers, they offer channels for more synchronous actions that are meant to happen live. And they also offer commands. So let's say you want to store info within a database, pull it later at any given time, they offer that for you. Also, a huge help has been native hot reloading. What this is let's say I were to make a change within a script. In many other game engines, if I wanted to test the change I made within that script, I would need to close out of the game that I'm currently running and then reload or restart the game and then get to that point to then make that sort of test to see if I'm at a good spot. This would be the equivalent of I'm changing the jump height of a character, closing the game out entirely, going through all the title screens, and then getting to the point where I can just press the space button. In modern game engines, this can take anywhere from 5 seconds to 30 seconds, to even more depending on devices. This is frustrating. With Turbo, however, if I were to, again, make that same change, all I need to do is make the change, make the save, and then because of hot reloading, it doesn't reset the entire game project. Rather, it'll just, again, update the script. You do not need to reload the game, and you do not lose any sort of sense of progress. So again, running that same platform scenario, I don't need to go through the title screen again, because it just updates the number, and I'm good to go. So that was one of the big reasons I ended up sticking with Turbo. And also, it's really easy to make a game within Turbo due to the massive amounts of tutorials and the great documentation they have on their site. However, Turbo is a low-level game engine, so they don't really offer too much outside of what's initially there for developers. So again, a lot more to get to a nice place, or a lot more work needed. So that brings me to TurbECS, a turbo entity component system, which is what I worked on. Out of the box, it has entities, which are containers for components. It has components, which are specialized data containers. There are systems, which then manage entities and components and adjust them as need be. Finally, I made a fair amount of documentation to help guide new developers, and all that work is under the MIT license. The reason I wanted to stick with a ECS framework as opposed to other frameworks, as I wanted to match what other game engines are doing, specifically modern game engines, so that every piece of work that I've done here can still feel familiar to those interested or those who want to move on to Unity in the future. For instance, on the topic of Unity, Unity uses a ECS framework in a way in which they have a game object component scenario where entities are their game objects and then components are components. However, it's not a new framework, believe it or not. But I wanted to completely revamp it as the old model fell short due to the state of some data structures, which then also led to a lot of unnecessary data duplication. For instance, let's say I wanted to quickly check an entity or make an adjustment to an entity. In some scenarios, what I would then need to do is make a clone of that entity within the game state. But then with that clone, meant I cloned every single component that was directly under it, even if I didn't want to, which frankly is way too much. So when starting out, I wanted to review the existing solution as much as possible, gather as much developer feedback, and primarily listen to their use cases. That then brought me to completely revamping the entity structure as a whole. Again, I wanted components to be in a separate location, to really minimize the amount of data that was being duplicated, as again, not all of it was really needed, and then also implementing a has-X structure. What this has-X structure is doing is that my game, well specifically my entity component system, has a lifetime system. For those who have used Unity, this is the awake, this is the start, this is the update, render, destroy. Those are all sort of based off of that Unity framework to, again, be similar to modern game engines. But then within this has-X system, I'm actually checking whether this entity has, again, something to do within the awake, has something to do within the update, has something to do within the render. And then from there, it's using that information to then check whether to go any further with this entity. For instance, let's say there's an entity with simply a text component and nothing else attached. We don't need to update that every frame. Traditionally, in the old sort of instances of TurbECS, this would not matter. And TurbECS would make a clone to the entity, then it would make a clone of every single component attached, restore, and then go from there. This was very inefficient, and then honestly made some devices lag a fair amount. But now with this has-X system, it creates this little gateway between all the entities before, again, making all those clones, just to make sure that what we're doing is actually necessary. So just by adding a small little data structure, I'm able to save a lot on computation time. But again, because I changed a large portion of the project, there were a lot of growing pains. For instance, in a find component call, where I was again referencing the self being the entity, since components no longer existed within the actual entity, instead they have a reference to where it is within the game state, I then need to send a reference to the game state every time I want to sort of specifically check more info on that component. Also, the way I created new entities needed to change. Previously, I would just create an entity by sending in a string for the name and then go from there. However, now I then needed to send in a mutable reference to a mutable reference to different components, which the entity would then reference but not directly copy into. But I wanted to put TurbECS to the test, so that led me to developing a little game, being Art Club After Hours. Why make a game? I wanted to test framework readiness and flexibility as well as common scenario goals. So the goals I set in mind were to have multiplayer servers, have at least one arts and crafts based minigame that people can play, and then have multiple emotes that people can perform in a space. Upon development though, I realized that there were a lot of things I really needed to add within TurbECS to make it more sort of akin to other game engines. One of the big ones was a time manager that would track the amount of time between each individual frame. This matters a lot. So for instance, to get back to the previous slide here, these otters, again, these are players managing each individual otter, but they don't move dependent on the amount of frames that have passed, but rather the time in between. Again, we use a time in between each frame, the delta time, for those who've used Unity in the time.delta time system. Because again, we don't want to limit it to we don't want to limit it to be based on the hardware specs of anyone's given device, but again, just the change of time in between. An input manager, I wanted to make sure that cross play was really easy to set up. So what then that turned into was that I needed to create a virtual gamepad for mobile, in which I then hooked up all those inputs with the initial gamepad system, or just mouse and keyboard, that normal players would have. So then I again merged those inputs and made one sort of big virtual gamepad that all these otters use. Again, these players here. Again, just to generalize inputs throughout all devices. Finally, an online manager. This allowed me to easily keep track of all the players within the server. And again, this is a completely optional framework, which I'm most likely not going to include into TurbECS, but it was definitely something that I used to streamline the sort of cycle of making an online game as a whole. With that being said, that brings me to my core contributors and contributions. For TurbECS, I was the main developer. I cleaned up a lot of old implementations and worked on a lot of documentation. Josiah Savory was my advisor, and he worked on a lot of review for any code and documentation. Thank you. And Alex Feigenbaum was the product development manager and developer within the TurbECS system. Finally, for our club after hours, I was a sole developer, and that was great. With that being said, thank you for listening.